Hi everyone, I hope you guys are doing great. Welcome to the third session in the series of the weekly sessions hosted by Kesari Lahore. In the previous two sessions, we have covered from the networking side with the basic integration and the basic ethics around the whole worlds of DevOps and the Kubernetes. In today's session, we will be covering the networking side and the security aspects of the DevOps and the Kubernetes. And for that sake, we have one of our most amazing speakers so far, Mr. Waleed Zafar. He's hailing all the way from SSI, Strategic Systems International Lahore, and he'll be covering today us is his whole insight and his knowledge on the niche topic of security, alongside and its take on networking. Furthermore, the session will conclude itself with the basic presentation, and after that, you guys will have access to a lab that will show you the hands-on practices that you guys all should do while practicing Kubernetes. Furthermore, just like the previous two events, you guys have the chance to win the certificates and the badges by completing two activities. For the sake of certificates, you guys can stay till the end, fill out the form that I'll share with you guys, and for the badges, you guys can head straight to cubecamp.kcd.org and complete your exercises to avail the badges. So far, so good. We have released about 200 badges and it's the same number with the certificates. And people who were very beginner and in the world of Kubernetes have really got a lot out of this. So you're gonna wait for about 2 more minutes, and then we're gonna start our session, and Breeze will take on the virtual stage. So we're gonna wait for a while. In meantime, if there's anything really that you want to add, you can while we're waiting for others to join.
Um, Hi everyone. No, nothing. Let's get into the session and let's learn some Kubernetes security.
Okay, awesome. I'm just managing the custom layout from my end because last time I had this issue that the picture was overlapping with the presentation slides. Also, guys, you can drop your questions in the chat section of either on LinkedIn or on YouTube if you are lucky. And if you are lucky enough, you guys can also drop your question on Twitter. So we'll be answering that alongside the session. And if you guys have like any specific questions for which you want the speaker's input upon, you guys can wait till the end, and Willie's gonna answer them for you. Okay. And okay, we are at 10:35. Waleed, the stage is all yours, and let's start. Let me add you on the stage. The custom layout. Okay. Okay, perfect. Let me remove me.
Hi everyone. My name is Waleed Zafar, and today we will be discussing security in Kubernetes. A little bit about me before we start. So I am a DevOps engineer at Strategic Systems International Lahore, and part of my day job is to make sure that the Kubernetes cluster that are being used are configured properly, are secured properly. Um Other things about me, yeah, so I am also a Microsoft certified cybersecurity architect expert, as well as a Google certified cloud architect professional as well. And I love cloud and I love cybersecurity. I'm a wannabe, I would say wannabe or a noob hacker as well. I try doing hacking stuff. I'm not very good at it, but I do. But that's about me. So let's jump into the session for today. All right. So uh, on our agenda are several things. We will discuss defense in depth. Defense in depth is something that you will hear on every security course that you will take or might take or have taken. Basically, this concept is how security should be implemented. Is the I would say the best practice to implement security. Defense in depth just means that we have a layer has its own defense mechanisms in terms of cybersecurity so that the blast radius of an exploit can be reduced. Uh, then we'll discuss network policies, which are basically used to control traffic in and out of the Kubernetes cluster and its objects. Then we will discuss TLS offloading on Ingress, which is basically how you can uh, serve in inherently insecure application, say for example on port that works on port 80 on port 443, and how we can reroute traffic to that. Then we'll talk about securing nodes and verifying binaries. These are basically best practices in making sure that your worker nodes and your master nodes are configured properly. We actually have a very interesting case study at the end that you'll see that shows that how important it is for us to secure those nodes. Then we will discuss about server accounts and role-based access control. This is basically I would say the most important pillar of Kubernetes security. Is basically how you assign roles to pods and you give certain amount of permissions to a pod. And then we have security context. So this is basically a very advanced security topic, especially in terms of how you want to control your pod or container access to the underlying Linux kernel, and how you want to put some restrictions on how container and the underlying application code inside the container runs. Then we'll discuss image and container vulnerability scanning using like Trivy, and for premium we also have check marks and stuff like that. So Qbench, this is basically about compliance. So basically we trigger your Kubernetes cluster securely, and Kubebench is basically a tool that runs against your spun up environment, your cluster, and shows how compliant your cluster is. Uh, Lastly, we will have a lab, and for the lab, I and Adil developed a tool which will we be revealing as well. So applications that are running in that cluster. Then we have container or pods. If someone gets inside a pod, he might be able to communicate with other pods, download malicious software inside that pod and use that to his advantage. And then finally we have the code. There are multiple facets to securing code. Number one, it's an intellectual property. You want to make sure that no one gets to your code, so you need to stop people from getting to your code. And then we have people can introduce vulnerabilities and introduce malicious lines of code into your code, and that is a intellectual property. In summary, we have a lot of layers when it comes to Kubernetes that we need to protect to make sure that we have a secure environment for our applications to run it. All right, uh, let's talk about network policies. So, network policies are basically uh, they are basically definitions that define how groups of pod can communicate with each other and what and other network environments, and what are the limits of pods. So basically there are two types of policies. Number one is an ingress policy, and number two is the egress policy. So ingress policy, as the name says, are policies that govern incoming traffic to the pods. Egress policies, on the other hand, govern there's one thing. So without the absence of an ingress policy, all incoming traffic is allowed by default, and when there is no egress policy, all traffic going out of the pod is allowed. So we need to make sure that if the pod does not need that, we need to have uh, network policies in place. uh, but there are a few defaults as well. So if you do not have a default policy, what will happen is that it will deny everything. So it will not allow anything. So uh, all right, let me reiterate. So if there is no network policy in place, what will happen is that all traffic going in and out of the pod will be allowed. However, if there is one policy that, for example, there is an ingress policy that selects the pod, what will happen that unless any traffic that is explicitly allowed, all other traffic will be blocked. So if you have a what is called a default deny policy, so if you have a an empty policy with ingress and egress blocks that just selects a pod, what will happen, all incoming and outgoing traffic of that pod will be blocked. uh, so you if you have network policies in place, then you want to make sure that uh, the pod is allowed to, or the certain ports that are used for the communication are allowed, so that the application work can work as intended. um, all right, so there is a network policy example. Let's walk through it. So its first three lines are nearly something that you'll find in every Kubernetes object definition. And of course the metadata that it contains the name. If we walk through the policies, it what it does, it selects the pod. It has a policy type called egress. The label is that role. The label is role has a value of API key. If we walk through it, there is a policy type called egress. So it's on egress, which means all ingress is allowed because there's no ingress block. So it's allowing it to have egress net of 203.0.113.0. So that subnet you are allowed to communicate over port 443. The policy actually the traffic on port 443 destined for that certain subnet. All right, let's move forward. So TLS offloading on ingress. this is a very important topic because most of these services that Kubernetes has designed, and if you have like a inherently insecure service that uses, for example, a insecure protocol like HTTP on HTTP, so what you can do is you can actually initiate the client or your customer actually initiates your connection, and then it reaches the ingress. That is basically your service, your client reaches the ingress. The ingress does the TLS termination. It has the TLS certificate stored as a secret. It's referenced as a secret in the ingress, and the ingress then after doing that, it actually then routes the traffic back to the backend service on port 80. So inherently the communication between the client and your Kubernetes cluster or the service is over 443, but internally, the service itself is listening on port 80, and Ingress is handling all of the SSL offloading and routing of the traffic. So basically, how to do that? We need to have a block resource with TLS secrets, which is basically a certificate and the key. And you need to have the ingress, and then the ingress should have the backend resource for the particular service that you wanted to route to. That's an example as well. So if you let's walk through this example, you can see that again, already said, the first three lines you will find in every Kubernetes object. So you see that the spec has a TLS block. It specifies the host and then the secret name. So secret name is basically where you have configured a TLS certificate as a secret and stored the key and the certificate as base64 encoded values in it. And then you can see that what happens that if a request over example.com comes, what you need to do, you need to, and if the path is slash, that is basically the default path, you need to reroute it to the backend service of example service that is written. That is, if you see my mouse, it's on port 80. So yeah, that is how we can handle TLS offloading using Ingress in Kubernetes natively. Um, all right, so let's talk about securing nodes and verifying binaries. Um, Securing nodes and verifying binaries. So this, as I said, there's a couple of best practices that we need to follow to make sure that our underlying infrastructure of our worker nodes and our uh, master nodes are actually secured, and we are using TLS offloading. So this is something. If you walk through these steps as well, you can see that these are best practices applied to nearly every digital asset that you own, or every digital machine that you will use for anything, for hosting an application or for running workloads or for securing node and patching, because there are new attacks coming out every day. There are new CVEs being discovered. So we make sure that we are running the latest and the greatest version of software possible, operating system and application likewise. Then we can minimize the attack surface. So minimizing the attack surface means that we do not need a lot of services to host Kubernetes. So we can use number one, use a minimal OS like Core OS or Flatcar or Bottlerocket, which is specifically designed for running containers and hosting Kubernetes. And then we can also we can also turn off non-essential services, even if you have like a Linux machine, a Ubuntu machine. We can turn off the services that we're not using. Hardened node configurations, again, we have CIS benchmarks for this as well. So we use the CIS benchmark as our reference, and then we do what is suggested in those in those benchmarks and make sure that our node is compliant to those standards. Then we that is a given that we enable the firewall and harden SSH. Basically, hardening SSH involves restricting or disabling password-based SSH access and using key-based, basically key pair-based SSH access. And if it's a cloud-based service, you can use a bastion host to basically uh, not um, expose your service, or not expose your actual control plane node to the public on a public IP address. And the final point is log, log, and log. So it is very important that whatever happens in your environment is logged, because if in any case, even if it's an application failure, it's a hack, it's something wrong with the infrastructure, logs are the first source of information and a very essential source of information about what went wrong. So it is very important for you to log and to make sure that these logs are secured and no one can, and their integrity is maintained and no one can modify them, so that you have an exact chain of events that led to something going wrong. uh, uh, Logs are also very important for performance monitoring and other things, and but from a security perspective as well, they are very important, so that you know what API calls were made or what's new, new applications were spun up, new pods were spun up. So it is very important. All in all, it's very important for us to log and nearly log everything. Uh, let's talk about verifying binaries. So this is very important because we download something and we say, all right, that is coming from a source, that's all right. So there's a very simple step in verifying binaries. So first you make sure that you download it from an official source, and number two, then you calculate the checksum of the binary using a tool like Shasam, for example, and then compare the file that is calculated to one that is provided. If they both match, then you are good to go, because the integrity of the file is intact and it has not been modified in transit. If they don't match, it means the file has been tampered with, or it has not reached your service properly, or some packets were lost, or something. Just making sure that the file is not what it should be, what it should be. So basically, the uh, checksum allows you to verify all right. So this is one of the most important topics of Kubernetes, that is Kubernetes security, that is service accounts and role-based access control. Um, so what are service accounts? Let's start with service accounts. So service accounts are basically used to provide an identity for pods and services to interact with other pods and services, as well as the Kubernetes API. So basically, they give access to commands to actually run commands such as kubectl, get pods, kubectl, delete pod, for example. And they are like, if you have experience with cloud services, they are like roles for EC2 instances, or for example, to assume an identity of a user to perform certain tasks in the cloud provider. Same service account actually allows the pods or services to assume an identity of a user that has a certain amount of permissions to do uh, to interact with the Kubernetes cluster and the Kubernetes API. So basically, there is a default service account that is assigned to every pod if no other service account is explicitly mentioned in the pod definition. So there the problem with the default service account are, there are a couple of problems, basically. Not a problem, but a couple of problems. So we have it does not follow the principle of least privilege. It does not have too many permissions. Basically, it does only have the basic permissions of service of a default API discovery. And if you want to do something with the Kubernetes API, for example, delete a pod, you cannot do it using the default service account. Um, and again, so then the question comes: what is the difference between a user and a service account? So uh, I think we have discussed a little about service account. Let's discuss about users. Users in Kubernetes uh, are a are different than service accounts in many ways. So user management is number one. Like for service accounts, you have an object that is named service account, but you have nothing for users. And user management is done using external example. In case of AWS EKS, there is I think there is you have the users that they have certain roles attached to them that allow them to then log into the Kubernetes cluster to use the Kubernetes service. And then you have users that are built externally, which again we have configs for users that they then use to interact with the Kubernetes cluster, and then they can actually use it to go into the cluster and do their thing. Service accounts, basically, service accounts are namespace. So they belong to a specific namespace, uh, and then they have a service account has a role, and then they have a principal as well. So they are more like, they are more in line with what roles do for EC2 instances than the user accounts. So, all right, let's go to roles and cluster roles. All right, so there are two types of, basically, when we talk about roles and cluster roles. So when we were talking about service accounts, so we have a service account. There will be a role that is attached to the service account, and then the service account will be, used by a pod. So basically, a role is a set of permissions that are namespace scoped. However, cluster roles are a set of permissions that are cluster wide, that grant access in every namespace nonetheless. So a role is a namespace. Well, it is limited in its scope, while the cluster role can grant access to all resources in the namespace. Let's talk about role bindings and cluster role bindings. So how do we actually attach the service account to the roles? That is done using a role binding or a cluster role binding. A role binding basically is for binding a role to a service account, and a cluster role binding, as the name suggests, is for binding a cluster role to a service account. Um, these are a few examples of service accounts and their role, service accounts and roles. So you see first CR again repeated, and then we have a metadata. We actually specify the namespace. If nothing is specified in the namespace, default is already assumed. Uh, and then we have a role definition. What it does, it is a role for the default namespace, and it allows whatever it is attached to get, list, and watch pods. So it can get kubectl get pods, it can do a kubectl list, all right. So then there is a role binding example. So we created the my service account and the pod reader role in the previous slide. How can this be then linked together? So there's the role binding definition, in which we are telling it that this is the subject, that this is the service, and this is the role, uh, and this will actually create the binding between the role and service account. This is basically this will attach the permissions of pod reader to the service account. And then how do we use it? So that's an example pod definition in front of you. What it does is it actually lists the pod, and you can see that we have in the spec we have a service account name, so we are actually referencing the service account here. uh, it's called the my service account. So what it does with the spec, when we do the service account name, it actually binds that role to the pod, so the pod cannot do a kubectl get pause or watch pause or list pause. So that's to do with RBAC and service counts. Let's talk about security context now. All right. So basically, security contexts are used to define privilege and access control settings for pods and containers. Uh, these make sure that your applications are running with the appropriate security constraints and make sure that the principle of least privilege is followed. They can be, they can be defined both at the pod level and then at the container level as well. Um, but when you apply it to pod, what happens is that it applies to every container in that pod. So if you have like context is that it does control access to how your application interacts with the Linux kernel, but there is no support for Windows, so you cannot actually control access to how applications interact with the Windows cluster. In even on Windows, I believe that we have WSL2 that is required to run Docker, Docker, and then Kubernetes on top of that. So yeah, that's something that we need to keep in mind. All right. So you can see there are a couple of security context definitions here. The first one, we see that we have a security context on the pod level, which means that it will automatically apply to the container level as well. We have run as user 1000. So basically, by default, use when you go into the pod as well, and when you exec into a pod as well, you can see that it runs as a root. So if you want to restrict how the pod runs as, you can use the run as user and run as group annotations. And then if you see the next definition, you can see that we have a read-only file system is equal to true. What it does, it is used for cluster immutability. What it helps in ensuring is that no one can write to the pod file system. So if you have like people installing something, they wouldn't be allowed to. So this can be then coupled with run as a different user than root, and this will actually control your access to pod and make sure that the pod file system is not modified. There are a lot of options with security context, and those can be explored further. You can actually have a lot of control over how your application and your pods interact with the Linux cluster. Um, that again, this read-only root file system set to true, and what it is trying to do is it is trying to make a file output fail to create file system if the security context has been applied to it. All right, so yeah, image and container vulnerability scanning. This is very important as part of your normal software development lifecycle as well. You make sure that you continuously scan for vulnerabilities to make sure that your images and your containers are clean. Uh, vulnerability scanning, again, is something that should not only be limited to containers and your images. It should be a wider exercise in which your infrastructure, your other application, your bare metal applications, your services all should be scanned for vulnerabilities, and this should be a regular exercise as well. So basically, again, if we what is the importance? It actually identifies helps identify your current security posture, if you have any vulnerabilities and any sort of gaps in your defense that you need to work on. Then it's a compliance as well, because many industries like PCI, for example, many industry standards or data standards like PCI DSS or HIPAA might require you to do regular vulnerability scannings to actually comply with their regulatory standards. And then we have also have risk management. Basically, risk management, it allows, because when you identify a certain vulnerability, you know that what risk it poses, and then you can actually mitigate it. Or if the risk is acceptable, you can leave it as be, or you can even uh, try to transfer it by using a service like more uh, a service that has more responsibility on the provider than yourself. For example, switching from infrastructure as a service to a platform as a service, or a software as a service service, instead of using IaaS for hosting an application. Uh, that being said, there are a lot of tools that you can use for scanning Docker images and Docker containers. So we again, when we talk about vulnerability scanning, there are two types of vulnerability scanning. There is SAST and DAST. Software, it is, I think, static application security testing, and dynamic application security testing. So SAST is basically done on the code itself. So you scan the code to look for vulnerabilities and look for malicious code and bad code practices. Uh, and DAST is run against a running application, and you actually attack it, try to attack it, or the scanner tries to attack with the actual attacks, automated attacks, and sees what the application response is. So a couple of SaaS tools there is Trivi, Clear, and there is the Anchor engine as well. Also Chekhov as well. Chekhov, I've worked with Chekhov a little, but Chekhov is basically used for IAC as well. So it can scan Terraform code as well, but it also helps you scan image code as well. So Trivi, they're all open source code tools, so you can actually look at their code and what they do and how they do this. So when you're hosting web applications, you can actually use and we can also use Sysdig as well, Sysdig Secure. OWASP Zap, again, let's talk a little about OWASP Zap. So OWASP Zap is a very, you can say it has large amount of integration. So we have integrations with GitHub Actions as well. We have integrations with Azure DevOps as well. So this tool can be used then again as part of CI/CD pipelines to make sure that the or a couple of these tools, a SAST and a DAST tool, can be used as part of the CI/CD pipeline to make sure that you are performing SAST and DAST automatically as part of your build process and deployment process. Um, let's talk about CIS benchmarks, and I believe that will be our last topic before we jump into the lab. Okay, CIS benchmark. So CIS is basically Center for Information Security. It is a comprehensive guide um, guide for securely configuring Kubernetes clusters. It tells you uh, what the benchmarks. It gives you a set of benchmarks that you can test your Kubernetes cluster against to make sure that it complies with them. So cluster setup and how to do networking with Kubernetes and how to do authorization and authentication with authorization and authentication with Kubernetes, and how to do logging and monitoring with it, and how to do port security as well. So lot more here, and I think if you have these slides, there is a link to the benchmark at the bottom in the speaker notes as well. You can use that. And then we have Kubebench. So Kubebench builds on the CIS benchmarks. It's an open source tool uh, which actually runs against your uh, runs against your deployed cluster to make sure that it's compliant, to actually test compliance against the CIS benchmarks. So it 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 gives you a way to audit your configurations to make sure that they are compliant with CIS benchmarks. Uh, it generates a report at the end, so it tells you that this test passed, this failed. So you have a guidance on what guidance on what is missing in your Kubernetes environment and what you need to do. All right, so okay, this is one of my favorite things here. So there's what happens when you do not take Kubernetes API very seriously, but it happened all of. So it's about Tesla. Tesla in 2019 was hacked because they had a control plane. They had a GUI based Kubernetes dashboard that was unprotected and was open to the internet. So when we talk about it, let's go back to the layer defense model. You see that there are a lot of other stuff that you need to secure to make sure that your Kubernetes cluster is secure enough. So there is, for example, when you use GitOps and you use something like Argo CD for deployment management, you want to make sure that the Argo CD is actually configured securely as well, and it does not have access to, because if someone can go and get access to Argo CD, he or she can actually then deploy stuff on your Kubernetes cluster that you do not want. Same thing happened with Tesla as well. They had everything properly set up, but what they were doing was they were using I think EC2s as the baseline, and then they were spinning up the clusters on their own. So they were using an infrastructure as a service from AWS, and then they were using it to provision their Kubernetes cluster themselves. What happened that they had a GUI-based, GI-based, web-based Kubernetes dashboard that provided access to the whole Kubernetes cluster, but it was on a public IP, and it was not protected. There was no patch for protecting it. So the hacker gained access to that, and using that, they were able to get access keys and secret keys for the AWS environment, and then they went into the AWS environment and they spun up mining EC2 instances. They spun up a lot of EC2 instances for mining, and then I think Red Rock was the company that actually notified Tesla that you have this problem, and then they were able to patch it. So you need to make sure that not only your Kubernetes cluster, but all of the services that interact with the Kubernetes cluster are secured properly as well, because this can lead to situations such as this. So they again, and it is believed that they had access to a S3 bucket that had proprietary car training data, and I think it was not stolen. That's what Tesla reported, anyways. Uh, but again, this is a lesson for us to make sure that if we are using services like Kubernetes, we make sure that the Kubernetes cluster, and I'm repeating this again, not only the Kubernetes cluster, but the infrastructure surrounding it and the environment surrounding it is protected as well. Um, that's it from my side. So, are there any questions, and even if there are, type them below. And in the meantime, we'll jump over to the lab. Thank you.
Thank you so much for the amazing session. I'm really glad that you guys are live. We're gonna wait for like a few minutes and then we're gonna go for line. Now, if you guys have any questions, then we'll get started and then get some proper questions. There are a few already in the chat, and then answer those. And then after that, we'll jump into the live. So, let's see. There are a few questions to confirm. We're not getting more. And so, yeah, okay. And then, and then, and then,
All right. So, yeah, I went offline. I had to change my position as well.
okay.
All right. So,
So,
let's.
let me just fetch a few questions from chat and then go into the lab. Let's see. And then,
Um,
okay, there will be some, I guess I've been the phone and get a the next the common that is discussion, then find the diamond plate and that's in the both of the hands. Moving forward, there will be nothing. Always secure the bonds in numbers, Instagram, and numbers.
Moise, I cannot hear you.
Then,
Hello.
that's all.
All right. Okay, Moise, can you mute yourself a bit? I think you. Thank you. Thank you very much. Can we secure pods using Mac OS? That is the question. We uh, First of all, I do not understand what do you mean by securing pods using Mac OS, and if cannot on Windows. So I think it's related to the security context question. Uh, yes, because Mac itself is based on a Unix, subsystem, so it's built upon Unix. So the system calls to the underlying kernel are some of them are same, some might be different. Uh, but again, uh, yes, we can, but that's it. I think uh, for that question, is there any other question, or we should go on and start the lab? I think we
Is my
should.
audio better now?
Yes, it is. Yes, it is.
Okay, thank God. Okay, let's just move to the next question. Okay, let me
Yes,
switch to
it's.
find the next question. Okay, there's again another question from Akib. He said that is the container security not enough that we have to apply port security as well?
Uh, No, number one, no. Container security is different from Kubernetes security in a number of ways because, and I think Adil can also elaborate on that. Container are just a subsystem of, you can say, a part of a Kubernetes infrastructure. So there are many other layers that you need to protect. So and essentially when you're saying pod security, why do we need pod security? Isn't container security enough? So pods can essentially contain multiple containers. So if you have it will, number one, be uniform for you to apply security at the pod level, so both containers or many containers that come under the pod are protected. And number two, there are many other you know there are many other, I would say, components to Kubernetes that need protection. So that's why container security is not enough.
Okay.
All right.
There's another question from the same guy. He asked about the hack that you elaborated happened to Tesla. So he said that did you mean that Tesla space in AWS environment was hacked?
Yes, the Tesla organization, they were using AWS for EC2 instances, for spinning up EC2 instances, which they used to host their Kubernetes clusters. So what happened was the hacker got access to a, again, web-based interface that was used for Kubernetes management, that was unprotected. They went in and then they were able to, using, because they had access to the Kubernetes cluster, they were able to get credentials to their AWS environment. They logged into the AWS environment and they spun up uh, a lot of EC2 instances for the purpose of crypto mining, basically. Uh, that is what happened.
Okay. There's a comment over the session where said that the session is not a cup of tea for beginners, I think.
Yes, security is something. Yes, it's even when you talk about computer science, it's, I think it's a very advanced field, and then you talk about cybersecurity. It's an even higher tier inside the computer science, space. So yes, it is a hard topic, but once you get hold of it, it's a very, I would say, you will love working on it if you are interested in security. So yeah, that's my answer.
Awesome. Awesome. Okay, I guess those were the comments. Let me just quickly check the LinkedIn as well. So nothing special there too. Okay, I think we should jump to the lab. And
Sure. All right. I think Atul is here as well. I will share my screen, and then we also have an announcement to make. Adil, can you go ahead with the announcement? So we have actually developed a new tool for Kubernetes and for local labs, and Adil will tell you a little more about it, what it is. And in the meantime, let me set up my lab.
First of all, the rain just damaged our session, but you can see our aim is really strong here. And first of all, really sorry about that. And we will try to make your experience better for Kubernetes. And I know this session is not for the beginners, but you see, you need a room to learn from somewhere. So I think I got to know about Tesla hack. I didn't know this before. So you always there to learn something new. So don't think about this. This session is not for you for the beginner. You think you know about the Tesla. Tesla was hacked, and how much Kubernetes security is really important. You see, so Valit and the CNCF Lahore team created a KCDL control tool through which you can manage your and do the labs through GitHub Actions, and also you can perform the labs through your system. Like if you have a Mac, Windows, or Linux, you can perform the labs. You can create different labs with just a one click using Helm. And this is not, we are not just stopping here. We also created another tool which is called Kubernetes Playground, through which you can create your Kubernetes cluster on the code spaces on the cloud, and which is totally free. And we are trying to, making your experience better. So if you are a Python engineer, if you have expertise with Kubernetes, reach out to us. We would love to have you and represent Pakistan on CNCF. So that's all from my side. Over to you, Walid.
All
awesome.
right. So let me share my screen, and then you can see what the lab is all about. And let's start.
Okay.
Okay. Yeah. Okay. So I will probably share my entire screen so that nothing is left. Okay. Sure. Do tell me when you see my screen,
Yep.
Adil.
Your
All
screen
right.
is visible on the backstage. Otherwise, I have to remove you and myself.
Oh,
Okay.
before leaving, just give me a shout out when the screen is visible to the viewers as well, so I can stop.
The screen is visible. You can start. Also, like turn off your video feed so the screen, would stay.
Yeah, I will just stop my camera.
Okay,
Oh,
awesome.
okay.
Okay, I'm
Oh,
removing on stage.
All right, before we start, if you have any other questions as well about the lab, about the stuff, just keep typing it, and once we finish with the lab, we'll try to answer them all. Let's start. So, this is basically what you will see because it's an open source tool as well. You will see this code. So, it's a Python based tool, and what it does, it uses a technology called Kind, which is Kubernetes in Docker, to spin up multiple workers and master nodes and allows you to perform labs that you want. A little bit about the tool. Let me. Can we move it around? Yeah, we can. Sorry. So yes. So basically, it's already done. Let me do it again for just. Wait. You clone the repo. To run it, you will just run Python. And there's only one requirement for this. All of the other tools it installs itself. You just run the. You need to have Python to run the lab. And once that is done, you can either run this command or use kcdctl.py check. What it will do as it automatically identifies the operating system you have and then installs all the other, you can say, the dependencies that it needs. It installs Docker, it installs Helm, it installs kubectl, it installs Kind. Uh, for Windows, it uses Chocolatey. Even if you do not have Chocolatey, it will try to install Chocolatey first. Uh, that's the good thing about it. Okay, I already have a lab configured, but the good thing about this, what we have coded, is that once you deploy a new lab, it automatically polls the Kubernetes cluster to see if there was a lab already deployed, and it will delete it first before moving on before deploying the new lab. So about the labs, I have basically for this particular, right now I have coded three labs. One is a DNS lab, which actually teaches you how to do stuff with Kubernetes, how to do stuff with the CNI layers and the networking and how to manage that. The second lab here, service misconfiguration, actually taught is a little bit of a misconfiguration by, you can say, it's by design that you need to solve the lab. It's basically what happens is that uh, you have used the wrong, basically I have used the wrong URL to reference the uh, service that we need to talk to, and then you need to correct it. The third lab is the security lab that I will be also be showing here today. And then there is the fourth mode that actually took the longest time. It is a free for all. So what if you want to experiment with yourself and see what, we have multiple workers and multiple master nodes, and then deploy your own worker nodes. Of course, this is not recommended for production, but if you want to play around with Kubernetes on your local system and your local system has enough RAM, this is a very good way of deploying the cluster. There's no hassle of basically doing things however you want to do them, and then you have a ready-made cluster that you can then start deploying your workloads to, or start tinkering with. So all right, once when you are done with the installation process, and it will actually check for installation each time you run this application. So it will give you this interface. You need to write this is like so to use it, you use the command deploy space lab id. So we will be doing the security lab, which is also the lab number 3. uh, let's do it. So it will automatically, the labs have been configured using Helm, so they automatically deploy themselves to your cluster, the cluster that has already been created. Uh, so and it automatically switches your context to that particular cluster as well. So you do not need to do any other thing. So once this is done, you can actually go over to your command prompt and run kubectl get nodes. It will show you that it has the lab 3 cluster nodes already configured and how many of them there are. And you can even use a tool like Lens, which I'll show you in a minute as well, because I think it will take around 30 seconds to do. So for this particular lab, we have a couple of tasks. We have actually several tasks. So there is a task where we have TLS configured on an ingress, that is this thing for service on port number 80. Some laptops might not pick up because the survey because the certificate is self-generated, and self-generated certificates are sometimes by design or organization policies do not allow us to access websites that have do not have certificates with C do not have approved CA certificate authorities. Then we have a lab about network policy where we have already have a network policy in place that is denying everything, and we need to modify it to um, make sure that it certain communications can happen. All right, it's deployed. Let's go over to our command prompt or PowerShell or any other tool. Uh, Okay, this we don't need to know. Odds. Okay, there's one, but before that, let's do this. So you see, we already have these deployed. So we have the control plane server, which we are interacting with using kubectl get pause, and then we have the two worker nodes that are running the workloads. If you go over to the Docker desktop as well, you can see that it is running all the three of one, and really, you can see these two are also serving on port 30,081 and 30,080. Basically, there's a little bit of a configuration that you need to do when you are running kind Kubernetes in Docker. So when you use services with them, though, you have to make a certain amount of changes or tweaks. But let's get into it. Also, let me show you how Lens is, what Lens is. So basically, Lens is a graphical user interface for interacting with your Kubernetes clusters. And it's a very handy tool, especially when you do not know commands and how to do stuff. And it actually is a very click and click tool. So we can of course go to this is the already I have configured it, the kind lab 3 cluster. It picks up the context automatically. So if you deploy this lab and you have kubectl installed, uh, Lens will automatically do it for you as well. So let's wait for it to load so I can show you this as well. um, shouldn't take too much time, to be honest, because it's a local server. Okay, let me go in from here. Okay. Is it connecting? Okay. All right. I think I might have to restart Lens, but let's get into it. So when you start this lab, you can see that there will be a couple of namespaces, or maybe three namespaces in this that you need to use. This is default, the setlab, and the secured namespace. So default namespace, if you default namespace is the namespace that is used for the ingress things. So we have set up the ingress. There is a port that we are listening on, and then you can actually, if you go over to this your browser and you open the port 30,080, I think because they have a little bit of security implemented, so there is the SSL protocol error, but it is serving on HTTPS, that thing. So it's also serving on 80 if you remove the HTTP from it. See, probably, yeah, it's working. So you have the node port service configured. All right, and then the first task of the lab is to make sure uh, that, let me go into the namespace. So if you go through it, you see that there is an external pod. So the external pod needs to communicate with a pod in the secured namespace, which is the accessible pod, but it should not, be able to interact with the inaccessible pod. That's the first task of the lab. Then also we have a read-only pod. If we actually go into the read-only pod, this is to show you how security contexts work. Uh, if you go to the underscore pod, all right, wait, sorry. So kubectl describe pod, if we describe this pod, we will see which one is it, read only pod, that it has a security context configured. uh, if we go into it, both message, wait, can you give me a moment, guys? Okay, so yeah, we're back. If we go into this, it's in the second lab. We go into it, so you can see that it is a read-only pod, and if you describe it, you might see the security context here. Um, image ID environment, initialized pod restart. Okay, let me keep it here. Edit. Yeah, it does open it up. Okay, so if we go down, you can see that it has the security context read only file system has been true. So it means that you cannot do, you should not be able to write anything or to, install anything on the root file system. If you were to, go to the logs, we just cross it out. Yeah. If you were to just get the logs for this, logs, you'll see that it cannot, you know, uh, create a test file at the root file system. That tells us, because it's a read-only file system, you cannot make changes to the root file system. All right, so what other tasks do we have? In this, we also, I think if we go to the SecLab, one, there's this one, there's the RBAC test pod. So we have already have a service. If you actually describe or get the logs for this pod, let me get this for you. um, RBAC test pod, test. You see, it says that we are not able to list any resources. Now, we discussed something in the lecture as well, that was service accounts. So service accounts allow us to give this permission to a pod to interact with the Kubernetes API. And we already have one configured, I think, in this environment. If we can get the current service accounts using the get sa command. Um, you can see that there is a default. Oh, that's it. Okay. Spaces. You can see there is a lot of labs that have already, they're already there are a lot of service accounts. So there's another misconfiguration as well, because the account that you want to use to get paths is in a separate namespace that should be in a different namespace. So what should we do now? If let me walk you through this. We can go and we can just edit it out. The club now found. Oh, in the default namespace. Yes. No. It is. So we need a. I think we have one. Give me a moment. Should have one. Source account in the external NS. I think we have one. Yeah, there's one. Yes, yes. This one. So I think this was not. There's the cluster role binding as well. Okay, it's supposed to go. Okay, let me get. Can say that there's a lot of already enabled for us. So you can see that there is this service account, there is this cluster role called pod reader, and it is now, if we think about it, it is uh, referring a cluster role. So again, so we don't have any roles in this, but we have cluster roles. Cluster roles are roles, again, that was discussed during the lecture as well, that give access to all the resources across the cluster, regardless of the namespace. So what we need to do is to get service accounts, uh, get cluster role bindings if we have. LEBINDING. We have a read-only pod. Yes. Oh. Okay. I'll get this. We do have one for pod reader, I think. Here, yeah, there's the binding. It's for the cluster role. That's pod reader, and if we describe it, uh, so you can see that it is for the pod reader account in the SecLab namespace. So if you get the service accounts in the SecLab namespace, I'll be able to see it, but there is nothing. The service account itself is missing. So we can just take it and apply the service account. If we do that, there's this one. Oh, yes. Okay. Close to QNS. Okay, so that is missing. That's something that we will code on the go. So we can do that easily by um, actually using the service account namespace, and also that's one of your tasks. Other than that, there is the networks policy one. So if you want to get the network policies, you could just get np, I think. um, Network policies, I think. and secure. We- Oh yeah, you can see that it is in the SecLab that is default denying everything. So you need to allow egress and egress to a certain pod within the SecLab namespace, and there's a lot of tasks. So yes, I think the now the repository is available, so you can get on with these tasks. And there are, I think there are no other questions as well. I think I will post a link to the GitHub of this particular lab and this particular tool, and you guys can just install it on your local system, um, and then we will be good to go. And are there any other questions? Are there, Moise?
Yeah, there are a few. Let me just quickly add them on the screen.
Yep.
There's a one good question asked on Meetup, and I already answered it, but I want to, repeat it again. So the question is, what are the best practices for designing RBAC, role-based access policy, in Kubernetes to minimize security risk?
Okay, so yeah, this is a very good question. So first of all, you follow the principle of least privilege. That's very important. That you do not have cluster roles or roles that have more permissions than they require for whatever purpose they want to use them. And then when we discuss this as well, there's CIS benchmarks, so you can use those benchmarks to make sure that the authorization process and the authentication process that you're using up to the mark that the CIS benchmark suggests them to. uh, that's from my side. All right, there's, I think I see another. Is ingress for incoming traffic for pod and egress for outgoing traffic from pods? Yes, in network policies, the ingress block is for incoming traffic and the egress block is used for outgoing traffic. Yes.
Yeah, you also have to learn about to and from.
To and from, yeah. So I think Kubernetes is one of those tools that has very good extensive documentation with examples. So if you were to go to the docs.kubernetes.org, is it? You will find that they have explained everything and they have examples embedded in the document. So you uh, can, in most cases, at times find what you want in the docs as examples as well. Okay,
There's
what are
another
some
question. What are some common security vulnerabilities in Kubernetes deployment?
on Kubernetes deployments? Common security vulnerabilities. Good question. So basically, I would say number one is there at times the access to the Kubernetes cluster at the user level is not configured properly. A lot of people are using the same user account for getting into the Kubernetes cluster. If, from what my experience has been with Kubernetes. Any other common vulnerabilities? Vulnerabilities. It can
Image,
be. Yeah, yeah, yeah. Go ahead.
yeah, image
I think you were
vulnerabilities. I
saying.
just want to add.
Okay. So it's like if you are using an older version of Kubernetes that is all that has some identified vulnerabilities in it. Uh, so they have I think a quarterly release cycle. So they have like four versions each year, and make sure that you're running the latest one. And then I think yeah, it's usually about service misconfiguration. Also is one of the common vulnerabilities that you can find. So services that should not be listing on node ports are listing on node ports, uh, instead of using something like a cluster IP which routes it within the cluster. They're using hard coded node ports so that even that service is accessible from the internet. That is also a very common mistake that people do. uh, okay.
Okay, moving to next question.
Yep.
Most one is asked what is slash and labs switch
Ah,
does.
that's the namespace switch. So if
I
you want
already
to specify, okay, yeah, this is for specifying the particular namespace that you want to go into.
Okay. The same question for the same thread. What are SecLab? What SecLab tells?
It's just a namespace. It is what I wanted to name it as. It's
Okay.
so basically, what is a namespace? Namespace is your, I would say, like a resource group for containing a certain amount of resources, Kubernetes resources. So you want to group them together, you group them into a namespace.
Awesome. Okay, is a question for the tool that the team has built. He has asked that how we use kubectl commands in PowerShell.
Uh, okay, you need to install Kubernetes kubectl for that. You have a kubectl binary that you need to install, and then you will be able to use kubectl commands in PowerShell.
You know what I give answer to this one? I guess by typing you can use kubectl command.
Yeah, that is also a very good answer because it will automatically install kubectl for you.
Nice. Okay, here's a
Okay,
question from
a lot
Ankit.
of a lot of people also ask from where just lead created the environment in second and just get started with the lab. So can we just
Oh,
share the repository link or make it public?
yeah, we should, yeah, let's do that. And basically, it's an application that uses a lot of underlying tools, including Kubernetes in Docker and Helm to create the lab. It takes a lot of code, but it is like Terraform. So it takes a lot of initial effort, but then you just do deploy lab 3, and Terraform you would just do like a Terraform create. So
Also, if you
this
have a
is.
slow system, you can use
Uh-huh.
GitHub Actions. I just want to add one add-on that in case if you are so slow system, like you are a student and you are passionate, like we were passionate. I have a 4 GB RAM system and I try to use Kubernetes at that time. So if you are passionate like that, you can use GitHub Actions to do your labs. I can give you a just short brief, or Waleed can also add on it. Okay. Yes. Yeah. So this is currently private, but we will make it public. And you guys, if you have idea about Python, you can contribute and make it much better. And currently it's the beta version. We have created the GitHub actions, and you just need to type the following command: Python need to be installed. Like in case if the Python is not installed and you are trying and come to us like it is not working, then don't say that. You need to have installed Python installed with the kubectl.py file which exists, and then you need to check it. Just check the softwares are exist or what is your operating system, if you are using Mac, Windows, Linux, or whatever the system you're using. Or then you can deploy the lab 1, lab 2, lab 3, and it will deploy the labs. That's a very easy way to create a cluster and do the labs. Or if you have expertise, you can also add your labs here.
Uh,
And
Yes,
Mhm.
and also for the labs, I think it is protected, but always it's about GitHub. Use a pull request when you do things like if you want to contribute to it, so that we can actually review the request uh, and then see if the code is all right and it is not making any breaking changes to already um, working code. So that's just a heads up for those who will contribute and who want to contribute.
So this is our very first contributor, and we really give him a shout out. And he just helped us to make this software better, and open source contributions free for all. So that's all from my side. Still, if you guys have any questions from Waleed, and thank you, Waleed, The session was so awesome, but we don't know what were the weather conditions and such natural disasters. So things happened, but I think I learned a lot. And guys, if you have still any questions or any shout out to Willie,
Uh,
he just gave 1 hour and 25 minutes to this session and more than that. So give him a shout out in the comments. And stay on.
there are a few questions left.
All
Um,
right, let's do it.
Here
In
is one
Kubernetes environment,
in
it's all right. When you cloud, then directly when it is installed in Kubernetes environment, when it is installed, or when you are on cloud, then directly. Sorry, I cannot understand the question, to be honest. Uh, what if you guys can rephrase that?
Okay, he added to this. I'm not questioning. I'm trying to answer him.
All right. Okay.
Okay.
That is that is all right.
So we train people a lot that they are giving answers
And
to the questions in the comment.
that's very heartening to see as well. Yeah.
We have trained them so well that they are self-sufficient now.
Yes, someone asked a question on Meet Chat, and that's another good question. How
Uh-huh.
we secure our container images used in Kubernetes deployment? That's a
Just
good
give
one.
the spaces first.
This is a
Can
good one.
we secure our container images using what? Using
So
use. Can we
I can
secure our
repeat
container?
that.
Okay.
Can we secure? Yes, yes, we can. How then the
Yes.
question will be how we can secure our container images used in Kubernetes
Okay.
deployment.
This is something used in Docker security as well, and I think if I forgot to mention it in the that so you have hashes, container hashes, and then you have a concept of allowed and whitelisted repositories. So you can have a whitelisted repository, so you only have uh, you are pulling images from certain sources that you're allowed, and then you can use uh, I think it was an environment variable in Docker, but I don't know what is in Kubernetes. So you can set it so only digitally signed images can be downloaded. Otherwise, it will reject an image that is not digitally signed. So yes, there are, and then of course we mentioned about the image scanning vulnerability scanning tools. Many of them, the tools that we mentioned, actually scan images for vulnerability. So yeah, that again your this can then deployment can be a part of a CI/CD pipeline where the hash is verified first, then there is a vulnerability scan on it, and then it is finally downloaded into your system. So yeah, they can be used.
Awesome. So here's another. There's a. I think this is the last question. He has asked that can we say namespace is used for grouping our application for different environments?
Yes, certainly. That is why we use namespaces. If you have a single cluster and you want to host multiple environments on the same cluster, you use different namespaces. Yes. So all
Awesome.
the resource, yeah. So you make namespaces by environment, and then you group resources under those namespaces.
Okay, so people are asking that they need the repo link and they want us to make it public. We will make the repository public after the event and you guys can access it. And like every stream, there's the same question that is this video available after the live stream? Well, yes, the CNC of Lahore YouTube channel will have all the sessions and you can also see the
Yes.
live stream on LinkedIn as well.
All
Also
right.
on Twitter in case you're
Say,
outside of Pakistan.
I would say mostly we just take the Udemy courses which are free and select them like hundred of courses on my Udemy account which I never open them. So don't do like this. If you are very passionate to make this repository public, then prove it.
Yes, and this is a very valid point. So do not, especially when you do courses as well. What I think this is something wrong with me as well. I will pull in all the knowledge of the world. I will download all the books. I will download all the courses, and then probably do not have the time to even review one of them. So do not do it, especially if you want to learn something. You go stepwise. Take a small bit of the knowledge that you have, uh, learn it, and then go forward. And also, I think today the thunderstorm did a lot of damage to ours. think a lot of people were saying there was audio issues. So I'm sorry for that, and uh, I think we will give them the slides as well, because the slides have all of the knowledge. So this is something that I did. I made these slides very knowledge heavy, so you can actually go through the slides, and much of what is was covered by me during the lecture will be on those slides.
Awesome. Also, guys, alongside the slides, you will get the complimentary notes for the session as well that will be released under the Cube letter newsletter, and you guys can access them after like 2 or 3 hours of the session. So you can use that to reference as well. And in case you guys need any additional content regarding the session, you feel free to reach us out on the LinkedIn page. You can drop the text there, and one of the admins will reach out to you guys in about like 20 or 30 minutes. That's a very response.
All right,
Uh,
it's been
Thank you so much uh, for the nice compliment. And
right.
yes,
I think
we
it's
will
been 90
share.
minutes. I think the
It's
longest session.
yeah, the
Also,
long.
please don't forget to connect with Waleed on LinkedIn. And I think he is the only person from my connection who have such a deep and the passionate person for the Kubernetes and their security. So ask him question, and don't forget to connect with him. Can you just drop uh,
Yeah, I'm just
link?
doing that. I'm just doing
Yeah.
that. I have dropped Waleed's LinkedIn in the YouTube comment section, also on the LinkedIn as well, so you guys can connect with him.
So in the next hour, I think don't go for the Netflix or any Amazon Prime. Wait for us. We will share the queue later, which have another newsletter of this, which will we have all the explanation, which might be missed from our side. And another thing is,
Nice comment.
okay,
Uh,
so that this is a good one. And I don't also don't want to mention future fest slides which can't even copy from one USB to another, and it just take more than so so I think we need to wrap up. Still, if you guys have any question, we have a meetup, we have a WhatsApp channel dedicated for this. We have the Slack channel, we have the WhatsApp group, we have meetup. We don't have post like something, but we will definitely do if you're interested. Like if you can send me the post and I can just reply you back, I can also do this for you if it's work easy for you. Other than we have meetup, Slack, and everything for you, so we can help you with your Kubernetes journey, and connect you with the Kubernetes expert. And that's all. And Willie, do you want to add anything on Moise? Then we can wrap up the session.
nope, nope. It's been a great time.
The session went amazing, and I was just checking out if there's anything on the meetup or on the LinkedIn side. I think there's nothing. Let me just quickly check the Slack channel as well in case there is something there. Hmm. Okay, so nothing on Slack as well. And guys, thank you so much for your time. Thank you so much for showing up consistently for the past 3 weeks and for these 3 sessions. The Before we end this session, there's an announcement that the next session will be with an international speaker. So hold on for that, and it is going to be an awesome one. The certificates for the last week's session will be rolled out soon, and the certificates for this week's session will be rolled out by the Tuesday of the next week. And so far, I have got a lot of responses as well. And in case anyone hasn't filled the form, you guys have about like 10 or 15 minutes more after session ends, and I will close the form afterwards. If there's anything that you guys want to add or ask, you can ask now, because I'll wrap up the session from my end in next 2 minutes.
All right, guys. It's a wrap from me. I really.
Have a nice weekend to all of you.
All right.
Yeah.
Yeah. Nice
And
talking.
lastly, thank you so much, Walid, for your time, for elaborating this in such amazing detail, and also for your insights and innovation for developing the QCTL.
Thank you. Thank you very much.
Okay,
Yes.
that's one more minute, and after that, we will wrap up the session. And anyone who wants the notes, As others said, stay tuned. They will be released shortly after the event, so you guys can access that. Okay, Akib was asking again that can you please tell us about accessing the labs the last time?
Accessing the labs. So you,
And he said,
all right, so that's very simple. You clone the GitHub repository, you install Python, you run kcd ctl check, and then you write one. So four steps. Yeah,
and also he said, please.
yeah.
Uh, just subscribe to our cube letter. Uh, and then you will get everything you asked. We just fetch the good questions and we make the content, and then we will share the GitHub link, make it public, and share with you all. And the readme have all the document how to get started. We did not
Right.
cover how to install Python because we feel like you know how to install Python.
Is yeah, okay, right. Yeah, because the thing is we could not script it into the script itself because it was dependent on Python, so that's the only manual step you need to do. Yes.
Okay, I guess we are at the end of the session. Thank you so much, everyone who has stayed with us so far. And we will see you guys in the next week's session. Meanwhile, stay tuned with us. Stay active on our social channels. Feel free to reach out to any one of us if you have any questions. And there is a link in the comment section for the Cube letter, the newsletter for the case for by Casey Lahore. Do subscribe to that, and we'll see you guys next week. And if anyone has any issue regarding the certificate or badges, feel free to drop an email on cncflahore at gmail.com, and see you guys soon. Okay, guys, you guys can drop. I'm also leaving and wrapping up the session.
All right. Thank you. Bye.
Take care.